Hello students, in this video I am going to explain valence shell electron pair repulsion theory, important points and shapes of the molecules depending upon the number of bond pairs and lone pairs. And this is very useful to the board examination. Please subscribe to my channel, like, share and comment my videos. In the previous video, we discussed the formation of ionic bond and covalent bond in electronic theory of valency. The bond lengths and bond angles are expected to be the same, since the atoms that are undergoing bond formation, they have the same strengths. But practically it was observed that bond lengths and bond energies are not same when atoms form the bond are different. So whatever the defect we have, whatever the defect that we just discussed now, that is bond lengths and bond energies are not same, these defects are successfully answered or explained in valence shell electron pair repulsion theory, VSEPR. Now let us discuss the important points in valence shell electron pair repulsion theory. This theory was proposed by Sidgwick and Powell and later developed by Gillips and Nilam. So the important points here, electrons in valence shell of atoms in the covalent bond and in lone pairs as charged clouds that repel one another. See, electrons in the valence shell of atoms in the covalent bond and in lone pairs of electrons are considered as charged clouds or charged electron clouds. These charged clouds repel each other and stay as far as possible to minimize the repulsive forces. See, we know that electrons repel from each other. So, if they repel from each other, what happens? The stability becomes less. Therefore, the electrons in the atom, they try to stay away from each other so that the repulsive forces become minimum. If the total number of electrons in the valence shell of central atom of the covalent bond in terms of bond pairs and lone pairs. See, bond pairs means shared pair of electrons. Lone pairs means unshared pair of electrons. So, in the central atom of the molecule, the total number of bond pairs and lone pairs are known. Then we can, it helps us to predict the arrangement of those pairs around the central atom, and of course from which we can we can understand the shape of the molecule. The shape of the molecule depends on the number of valence shell electron pairs. Whatever be the number of electron pairs present in the valence shell of the central atom of the molecule, that gives the shape of the molecule. Pairs of electrons in the valence shell repel one another since their electron clouds are negatively charged. See, this we discussed already in the previous slide. These pairs of electrons tend to occupy such positions in the space that minimize the repulsion. Therefore, the electron pairs or electrons or the electron clouds, they try to move away from each other to the maximum distance so that the repulsion becomes least. The valence shell is taken as a sphere. Valence shell is taken as the imaginary sphere with the electron pairs localizing on the spherical surface at maximum distance. So, on the sphere of a valence shell, the electron pairs are situated on the electron pairs are imagined to be situated on the surface of this imaginary sphere, so that the repulsive forces become minimum. Therefore, the distance occupied by them is maximum from one another. The repulsive forces among the electron pairs decrease in the order of BP. BP means bond pair. Repulsive forces between bond pair is less than that of bond pair lone pair is less than that of lone pair. That means among the lone pairs, The repulsive forces are maximum and followed by bond pair lone pair and followed by bond pair bond pair. Now let us discuss the structure of beryllium chloride. In beryllium chloride, the central atom is beryllium. Beryllium has 2 electrons, and on the other hand, chlorine has 7 electrons. 1, 2. So this is here 1 electron, and here this is another chlorine atom. So here this chlorine and this chlorine pair together, and this chlorine pair together. Therefore, we get in this manner. Then we get beryllium Cl, and on this side also Cl. So beryllium is the central atom. So around the central atom there are 2 pairs, 2 bond pairs. These 2 bond pairs lie along the straight line. Therefore, the shape of the beryllium molecule is linear. So shape is linear and the bond angle is 180 degrees. Now, on the other hand, let us take BF3, boron trifluoride. In boron trifluoride, boron is the central atom. Boron atomic number is 5. Boron 5, 1s2, 2s2, 2p1. So there are 3 electrons in all in the valence shell of boron. So these 3 electrons paired with unpaired electrons present in 3 fluorine atoms. So this is boron 1, 2, 3 plus fluorine. Each fluorine has 7 electrons plus fluorine. So here also in this manner, plus fluorine. So this electron pairs with this electron pairs with this, and of course here is 1 electron, and this electron pairs with this. So here is 1 electron. Totally we get boron, fluorine here, 3 B boron fluorine bonds, they lie on the same plane. In this manner they lie on the same plane. So since 3 bonds are there and these 3 bonds lie on the same plane, and of course at the point there is a 360 degrees angle. This 360 degrees angle is shared by 3 bonds, therefore the bond angle is 120 degrees. So bond angle in boron trifluoride is 120 degrees. Now let us discuss about the methane molecule. Methane molecule formula CH4. Here the central atom is carbon. Carbon atomic number 6. So configuration 1s2, 2s2, 2p2. So electron picture for carbon here is one unpaired electron, here is one unpaired electron. So there are 4 electrons in the valence shell. 4 electrons are in the valence shell of carbon. So these 4 valence electrons pair with unpaired electrons present in 4 hydrogen atoms. So here carbon, it has 4 electrons, and here is one hydrogen, here is one hydrogen, here is one hydrogen, and here is one hydrogen. So these two, so this and this pair together, this and this pair together, this and this pair together. So totally there are there are 4 bond pairs. 4 bond pairs. Now the methane molecule is shown here. These 4 bond pairs, they orient themselves in the space so that the repulsive forces become least. So in such case, what happens, the molecule, the shape of the molecule is tetrahedral. Shape of the molecule is tetrahedral. And the bond angle is 109.5 degrees. So as 4 low bond pairs are there around the central carbon atom, the shape of the molecule is tetrahedral and bond angle is 109.5 degrees. So in this way, in VSEPR, valence shell electron pair repulsion theory, if we know the bond pairs and lone pairs, the shape of the molecule can be predicted. Now water molecule. Water molecule. What is the formula of water molecule? H2O. Central atom is oxygen atom. Central atom is oxygen. So oxygen atomic number 8, configuration 1s2, 2s2, 2p4. So electron picture for this oxygen. In 2s subshell there is a lone pair, and in 2p 3 orbitals are there. So there are 2 unpaired electrons. These two unpaired electrons pair with unpaired electrons of 2 hydrogen atoms. Therefore, oxygen here 1, 2 lone pairs, and this is unpaired electron, this is unpaired electron, plus hydrogen. This is 1 unpaired electron, and here this is 1 unpaired electron. So here this electron and this electron pair together, and this electron pair together. Therefore, in water molecule there are 2 bond pairs, 2 lone pairs. Lone pairs means unshared pairs of electrons. Unshared pairs. So how the shape of the molecule forms? This is oxygen. So here this is OH bond, this is OH bond, and here this is lone pair, this is lone pair. Because of these 2 lone pairs, water molecule has V shape. Just now we discussed that if the number of pairs are known in the molecule, that is around the central atom, we can identify the shape of the molecule and bond angle. If bond pairs are 2, then the shape is linear, that is both the bonds lie along the straight line, and the bond angle is 180 degrees. Now the examples for this type of shape is beryllium chloride and mercuric chloride. And if the number of bond pairs are 3, then all the 3 bonds lie along the vertices of an equilateral triangle which lie in the same plane. Therefore, this is a trigonal planar. The bond angle is 120 degrees, and examples for this BF3, boron trifluoride and boron trichloride. Now let us see if the number of bond pairs are 4, then the shape of the molecule is tetrahedral. So this is in this way. So directly I am taking the example of the molecule. This is methane. The bond angle is 109.5 degrees. Between any 2 angles is 109.5 degrees. Examples for this type of shape is methane, CH4, CCl4, carbon tetrachloride, etc. In this molecule, see, this is an example having 5 paired electrons. So number of paired electrons Number of paired electrons is 5. So in this, that means 5 bonds are there. 5 covalent bonds are there. Out of these 5 covalent bonds, this is number 1, number 2, this is number 3. They lie along the same plane. They lie along the vertices of an equilateral triangle. And above this plane, this is the another one and this is the another one. So if you imagine to join this bond to here, this bond to here, this bond to here, it looks like it is nothing but a pyramidal shape. So to this plane, above and below there are two pyramids, therefore it is referred as trigonal bipyramidal. So three bonds lie along the vertices of an equilateral triangle. Fourth and fifth bond lie above and below the plane of the molecule. Therefore, example for such a shape. Therefore, the shape is trigonal bipyramidal. Example of the molecule of such a shape is PCl5, phosphorus pentachloride. Now let us learn the shapes of the molecules if the number of bond pairs and lone pairs are known. See, number of bond pairs is 2, lone pairs is 1. Now the shape is bent. So this is the shape. Here A represents the central atom and B are the atoms which are bonding with the central atom. So this is the AB bond and this is AB bond and these two dots represents the lone pair. So examples for such molecule is sulfur dioxide and ozone. And in the next example, bond pairs are 3, lone pairs is 1. So this is the shape of the molecule. The shape is pyramidal. So the A is the central atom and B atoms are the atoms that bond with the central atom. Example for such a shape is ammonia molecule. This is water molecule. In water molecule, oxygen is the central atom and there are 2 hydrogen atoms bonded with the central atom and these two are lone pairs. So here lone pairs are 2 and bond pairs are 2. The shape actually, the expected shape is tetrahedral, but the actual shape is bent because of the more repulsive forces between lone pairs. Bond angle is found as 104.5 degrees. So in valence shell electron pair repulsion theory, the repulsive forces among the lone pairs and bond pairs present around the central atom gives the shape of the molecule. In the next video, let us discuss about the valence bond theory and hybridization. Please subscribe to my channel, like, share and comment my videos. Thank you.